starting chapter number 1 of Maths of Standard 9, that is number system. Now, for understanding this number system, you have to require some basic knowledge of different systems that we are using in Maths. Say for example, up to 8th standard, you might have drawn number line like this, in which in center it is 0, on its right hand side there are positive numbers, and on its left hand side there are negative numbers. These number system you have studied in 8th standard. Now, what are the different number system? Now we will start with our main topic. There are 5 different types of number system by which any number in Maths can be represented. That is, first is N, W, Z, Q and R. N is natural numbers, W is whole number, Z is integers, Q is rational number and R is real number. Now, see for example, which different numbers can be considered as natural numbers. So here I have written which numbers can be represented as natural number, starting from 1, 2, 3 up to infinitive. Your all positive numbers from 1 up to infinitive, they all are considered as natural numbers. Now coming to our second system, that is whole number. Whole number means W. This whole number is nothing but all natural numbers along with 0. That is, starting from 0, 1, 2 up to all positive infinite numbers, that system is our W, that is whole numbers. Now next is integers. As you can see in this number system, in center it is O, right hand side it are positive numbers, left hand side negative number. So this is called integers. Means on left hand side, starting from negative infinitive to negative numbers, then 0, then positive numbers starting from 1 to up to infinitive. All these numbers are considered as integers. Now next is Q, that is rational numbers. As you all know, this rational number, any number, if it can be represented in this form, that is P upon Q, but condition is Q, that is denominator, should not be equal to 0. If any number can be represented in this form, then such numbers are called rational number. And remember one thing, minus can be anywhere in this number. It can be in the numerator or it can be in the denominator. Or if it is present in both numerator and denominator, then that rational number becomes positive. So these are the examples, starting from minus infinitive, minus 3 by 4, minus 2 by 5, minus 1 by 3, 0 and positive such numbers. Such number systems are called rational numbers. And last is our real numbers. Real number means it is a part of rational number, and also in it irrational numbers are included. Now, which numbers are called irrational? Say for example, you have studied about square and square root. If you do square of 2, then you will say that square of 2 is 4. Suppose I am telling that you have to do square of 5. So you will take, so the answer is 25. Similarly, say for example, I am taking root 4. So I can say root 4 that is equal to 2. Root 9 that is equal to 3. But what if I take such numbers? Root 3, root 3, root 5, in which square root of the number is not possible. So such numbers are called irrational numbers. Any number whose square root is not possible, such numbers are called irrational numbers. Also, pi, which is a constant, this you have used when solving word problem in standard 8, whose value is 22 by 7 or 3.14. This is also an irrational number. Suppose any number after decimal, if the sequence is not repeating, then such numbers are also considered as irrational numbers. Say for example, 0.01, 001, 0001. As you can see, after decimal, As the number proceed one by one, 0 goes on increasing. 0, 1, 0, 0, 1, 0, 0, 0, 1. So this is the basic of number system. There are 5 different ways by which numbers can be represented. That is N, W, Z, Q and R. N is natural number, W is whole number, Z is integer, Q is rational number and R is real number. Now remember one thing. This in many exercises questions like true or false will be asked, in which you will be given a question like this: all natural numbers are considered as whole numbers, or all whole numbers are considered as integers, all integers are considered as rational number. Remember one thing, the number system in increasing order is only possible. Reverse situation is not possible. That means the number becomes 4. Say for example, if I am taking a number 0 and telling that all whole numbers are natural numbers, then my assumption becomes wrong. Why? Whole numbers have values from 0 to infinity, but this 0 is not a part of natural numbers. Means in such questions, remember one thing, if the number system in increasing order is given, then it is possible. But remember one thing, moving backward is not possible. Every natural number can be whole number, but every whole number cannot be natural number. Similarly, every whole number can be integers, but integers cannot be whole number, or integers cannot be natural numbers. Similarly, all integers can be rational numbers, but all rational numbers cannot be integers, cannot be whole numbers, or cannot be natural numbers. Means you have to remember this order, or in short we can summarize like this: N, natural number, is a subset of whole numbers. Means every element of natural numbers can be considered in whole number. Whole number is a subset of Z, that is integer. Z is a subset of Q, Q is a subset of R. This is the basics of number system. After understanding this concept, you will be able to solve exercise 1.1. Now moving forward to our discussion, that is irrational numbers. As we have discussed earlier, what are irrational numbers? If square root of any number is not possible, then such numbers are irrational numbers. Now such irrational numbers you will be required to be plotted on this number line. So after understanding this concept, you will be able to solve exercise 1.2. This is basic for exercise 1.2. That we will discuss later on when we will start solving the exercise. In this session, I am including all the basics that is required for this first chapter, that is number system. Now moving forward to our next session, that is the numbers can be terminating, recurring and non-terminating numbers. That is these 3 concepts I will be discussing at the last. Now some basic properties when irrational numbers are given. So for that you have to remember 6 different basic properties. First is if under root has 2 numbers, that is under root of a into b, that it can be written as under root of a into under root of b. Say for example root 15. So root 15 can be written as 5 is a 15, and both the given numbers are irrational numbers. Similarly, under root of a upon b means, say for example under root of 7 upon 3, that is root 7 upon root 3. Individually we will be writing under root terms in numerator and denominator. Next is if in bracket 2 numbers are given such that both the bracket have same number but only difference in between that sign. Here you can say it is positive, here it is negative. That is under root of a plus root b, root a minus root b. Then simple method, this square root you have to remove, that is a minus b. Say for example, here it is root 3 plus root 2 and in next bracket root 3 minus root 2. So simply This under root we will be removing, that is 3 minus 2. Our answer will be 1. Next is, if both these numbers were same, then you will get such answer. But what if such numbers are different? That is, in first bracket it is root a plus root b. In second bracket it is root c plus root d. Remember one thing. We will be taking this first number and we will be multiplying with these two. That is root ac plus root ab. Now we will be taking this second number and multiplying with these two. That is b into c plus b into d. And all the terms will be with under root sign. Next is root a plus root b whole square. Then simple. Here it is root a, so it becomes a plus 2 into bracket root ab plus b. Similarly here, if it is like this, root a minus root b whole square. So same formula, only you have to change the sign. Sign of middle term will only be changed. Remember one thing, this last term will have the same sign. Here it is positive, here it will be negative. And the last property for under root is, if you have been given terms, both the terms are same, in between there is difference of sign, that is one is positive, another one is negative. Here it is not given that it is root, so we will be writing a plus root b into a minus root b, that is a square minus b. Remember one thing, if any number is present in root form and you are doing it square, then the square root sign gets removed. That is, जे टोपी हो टोपी तुम्हारी निकली है. But if a number is given without square root, then we will be writing like this. We will be writing square in the form of power or degree on that number. Now this is the basic, after which you will be able to solve exercise 1.4 and your miscellaneous, that is basic exercise. Now for solving exercise 1.3, you need to remember what is rational numbers, what are irrational numbers. As discussed earlier about rational number, if any number can be represented in the form p upon q, condition is q is not equal to 0. And secondly, remember one thing, 0 upon 0 is not a rational number. 0 upon 0 becomes 0, so it is not considered as a rational number. But 0 upon 2, 0 upon 3, such numbers are rational numbers. Now, to understand these three concepts, terminating, recurring and non-terminating, we will be taking example 5 given in our textbook. That is, divide 10 by 3, divide 7 by 8 and divide 1 by 7. When you divide 10 by 3, you will get such 3.333. Means તમારું રિમાઇન્ડર ઓબ્ટેન થશે જ નહીં, તમારું કન્ટિન્યુ ડિવિઝન ચાલ્યા જ કરશે. Means whenever such numbers are repeated and there is no end to the calculation, then such numbers are called recurring number. And recurring number can be represented like this, with a bar on its head. Bar is to be written on the number which is recurring, that is repeating, 3.3 bar. Such are called recurring numbers. Now second example, 7 divided by 8. When you divide 7 by 8, after decimal point that there are 3 values at the end, in such numbers you will get remainder 0. Means your division after having some values, it gets cancelled out. Such numbers are called terminating numbers, that is 0.875. After these there is no further division possible. Means in such examples, here we are getting remainder 0. If you are getting remainder 0, then remember such numbers are called terminating numbers. If you are not getting remainder 0, then such numbers can be recurring or non-terminating. Now we will discussing what are recurring and non-terminating number. Divide 1 by 7. When you divide 1 by 7, you will get 0.142857. Then again your sequence will be coming. Again this sequence will be coming. Means never the time your remainder will be 0. Remember one thing, when remainder is coming 0, then that numbers are called terminating. If remainder is non-zero, then such numbers are called non-terminating. But if the whole number or a single number is repeating, then such numbers are called recurring number. As you can see in this, I will be writing like this: 1.482857 bar. Why I have done this sign of bar on these 6 numbers? Because they are repeating again and again in this sequence. But you can see in this,
साथ छोड़ूंगा ना तेरे पीछे आऊंगा, छीन लूंगा या खुदा से मांग लाऊंगा, तेरे नाल तकदीरां लिखवाऊंगा मैं तेरे